All right, here we go. We're going to talk about how to solve a system using Cramer's rule, also known as using determinants. So the determinant form of line is it's your standard form, pretty much. AX plus BY is equal to C. So when you're using determinants, you want to be in standard form, but you don't necessarily have to have A be positive anymore for this. Evaluating by a determinant. First thing you need to know how to do is find a determinant of a matrix. So we're just going to pretend that the matrix is A, B, C, D. In order to find the determinant of it, what you do is you start up here and you multiply this way. So it would be A times D minus, and then you come back up here and you multiply across this way. So this is step 1. This is step 2. You want to do it in that order, or you might have the incorrect determinant. So then this would be B times C. That's how you find the determinant. Another way of writing determinant is actually just having the matrix with vertical lines, almost like it's a gigantic absolute value. That is also saying that find the determinant. Okay? Now Cramer's rule. Cramer's rule is when we solve a system, we take two of our equations and we have to make sure that they are in standard form. And what you do is find three determinants. The first one we call D because it's going to end up being your denominator. And what we do for that is we use our A, B, C, and D, our leading coefficients. So we have A, B, C, and D. Now this is just the notes of how to do it. We're not doing it yet. The second one you do is you have your numerator for X. And to do that, you replace the A and the C with your E and your F, because that's how we're going to find X. But then our Y, B, and D stay the same. And then finally, you're going to have your numerator for Y. Since we're finding Y, we're going to replace our B and D, our Y coefficients, with E and F, and we're going to leave A and C the same. Okay? And then to find X and Y, you are going to set up a little fraction where we are going to do X will equal NX over D, and Y is going to equal NY over D. Okay? So, I know it's a little confusing, but that's the pattern. Once we do a couple examples, I think it'll make more sense. So, first thing you have to do is you have to make sure you're in AX plus BY is equal to C. You do not have to follow the rule of A having to be positive for these. Okay? So, first thing we have to do is we have to change this one to 4X plus 9Y is equal to a negative 5. And we have to change this one to 10x minus 27y is equal to 15. Okay? So now, we have to find three determinants. We have our D, then we're going to find our nx, and we're going to find our ny. To start with D, we just find the determinant of 4, 9, 10, and a negative 27. And we get that from just the coefficients of x and y. We multiply across starting here. So we're going to get 4 times a negative 27. So 4 times a negative 27 is a negative 108. Minus, now we're going to come back up here. 9 times 10 is 90. So D is equal to negative 198. Okay, now you stop with that for a while. Now we're going to go do it with x. So remember, since we're looking for x, we're going to replace the x's for the 4 and 10 with our negative 5 and our 15. And we're going to keep our y's because we just want to solve for x right now. Do the same thing. Negative 5 times a negative 27 is going to give us a positive 135 minus, come back up here, 9 times 15 is 135. So that's equal to 0. So nx is equal to 0. And then we have to do it one more time. This time we're going to keep our x's, the 4 and 10, but we're going to replace our y's with the negative 5 and 15. Cross multiply, 4 times 15 is 60, minus negative 5 times 10 is a negative 50, so that's obviously going to turn into plus, so we have 110. So to write our final answer, it's nx over d, comma, ny over d. That's our final answer. So x is 0 over negative 198, which is 0, comma, and then we have our ny, which is 110 over negative 198, and that's going to reduce to negative 5/9. And that's how you solve a system by Cramer's rule. I know it seems like it takes a lot of work, but let's think about the advantages here. What if the solution to the system was 12/23, comma, negative 5/17? As you were doing that algebraically by hand, it might get a little messy because of the crazy fractions. But if you're using Cramer's rule, that's what you're going to end up with is a fraction, and you're not going to have any issues. Number 2, why don't you pause the video really quick, and I would like you to set up your 3 determinants and find the 3 determinants. Try this part on your own really quick. Did you get the same thing I got? Do you have first this written as 16x plus 10y is equal to negative 14? If not, that probably caused you some problems. So D, we just use our coefficients for the x and y's. Our nx, we replace the x column. The ny, we replace the y column. We found the determinant of each, which is 80 minus 80 gave us 0. Negative 70 plus 70 gave us 0. And then you can see what we're doing here. We got all zeros. So what do you do when you have all zeros? Well, you don't really have to think much about all zeros or what happens. Just use the pattern. Nx over d, comma, ny over d. Can you divide by 0? No, you can't. So the question is this going to be no solution or infinite solutions? And because everything is 0, since, I mean, you're dividing nothing by nothing, is that really a problem? Not really. So we have infinite solutions. And again, that means they're the same line. Okay? So that's Cramer's rule. So what we're going to do really quick is we're going to do a big old word problem again. As mentioned before, we will have big word problems all year. This one, the first thing we have to do is read this very carefully. So you might want to pause and read this really carefully. And it tells us what to use for our variables and for our equations. So go ahead and read this very carefully. And let's see if we can set up a system. So we're going to have Cm, which is equal to 60m plus 1800. And then we're going to have Em, which is equal to 50m plus 2600. So if you read this carefully, it costs $1,800 to buy, but it costs more to operate. And the more expensive one is more efficient, so it costs less to operate. So we should have these two equations here. So then what we have to do is we have to, in B, we're going to find C of 100 and E of 100. So C of 100 is going to be equal to 60 times 100 plus 1800, which means that is 7800. And then we're going to have E of 100, which is 50 times 100, plus our 2600. And that's going to give us 7600. So what this tells us is after 100 hours, or I'm sorry, after we substitute this in, we're going to find out that the relative to cost that, in the long run, the more efficient one is going to cost you less money. And when does that actually happen? That happens in about 8.3 years, because this is in months. So if we think about it, we take our 100 months and divide that by 12, and we get approximately 8.3 years. Okay, and it's already cheaper to buy the more expensive unit. So it takes 8 years to start seeing the benefit. So we're going to solve the system and find out when we break even. So it says we can sketch the graph. So what you could do is you can solve it algebraically if you want to, because this is just the same variables pretty much. This is an M. So we could just set 60M plus 1800 equal to 50M plus 2600, and just solve for M. So that's going to give us 10M is equal to 800, divide by 10, and M is equal to 80. So it takes approximately 80 months for them to be even. If we were to sketch the graph, remember, your sketches don't have to be perfect, but it's nice to have the number of months and what it costs to run them. And this one starts out cheaper, but then it's going to get more expensive. This one starts a little bit more expensive, but it doesn't increase as fast because it's only $50 per month. And here's a nice little representation of our 80 comma at $6,600. Once you solve it, all you had to do is substitute the 80 back in for one of those, and you get your intersection. That's when they become equal. Anything after that, it's better to go with the more expensive unit up front. Okay, and that's that. So number 4 is just a review with a graphing calculator. To do this, all you have to do is remember your calculator likes slope-intercept form. So this one needs to be changed to y equals 3/4 x plus 7. This guy needs to be changed to y equals negative 3/5 x minus 3. You type this guy into y1, and you type this guy into y2, and then all you have to do is press graph with your calculator, and it's going to give you a little graph that looks a little something like this. And you just have to find that intersection point. How do you do that? After you graph, you press the second button, and then you press the trace button, which is going to say calc above it. And then you press number 5, which is the intersect, and then you just press enter 3 times. So enter, enter, enter. And the calculator is straight up going to tell you that the answer is negative 7.407, comma 1.444. Now, that is the answer to your system. Okay? This is Longo. I'm out. We'll see you soon.